Hey everyone, and welcome back. So in this tutorial we're going to take a look at ES6 classes. Now the very first thing you need to understand is that even though JavaScript is an object-oriented language, it does not have a concept of a class. So unlike other languages like Java or C#, which are also object-oriented languages, JavaScript is not class-based. Now you heard me use the term class. Essentially when we talk about classes and object-oriented languages, by class we mean essentially a blueprint for objects. So essentially the process is that you create classes which are essentially, like I said, blueprints for objects, and then you spawn off objects out of those classes. Now you can also extend classes by defining new classes that basically augment the functionality of the original classes. So this is all fine and cool, but the only thing is JavaScript uses what's called a prototype-based inheritance model. So essentially the way it works is that first you create an object, then you basically define properties and methods on that object, and then you instantiate new objects out of it. And the way that inheritance works in JavaScript is that it uses what's known as prototypes. So a prototype is essentially an internal property that every single object has in JavaScript that basically points to another object which this current object inherits from. So in order to illustrate the concept, let's say you have a simple empty object here. If you were to console log the prototype of this object, which could generally be accessed through the proto property, you see that in this case we get an object. If you open up the DevTools and Chrome and you expand the object, you're actually going to see that it has a whole bunch of properties. So the reason you see that is because every single object in JavaScript is an extension of the global object class, which has all these different properties and methods. And one thing you can see there is the constructor that points to the underlying object. So when we talk about the prototype is essentially a pointer, a reference to the object that this object that we created right there extends from. So when we talk about classes in ES6, we need to understand that classes are essentially just simply a convenience syntax. So classes, and by classes I simply mean the new class keyword in ES6, is just simply syntactical sugar for the traditional prototype-based model in JavaScript. So classes, as you'll see, don't actually introduce a new, object-oriented model in JavaScript. JavaScript still uses prototypes under the hood, and the new class syntax is simply a clearer and simpler way to define objects as well as inherit from them. So what I'd like to do in this tutorial is I'd like to walk you through the process of creating classes, working with classes, and the way I'm going to do that is basically on the left. I'm going to first show you examples using the traditional ES5 approach or the functional approach, and on the right I'm going to show you the newer ES6 approach that uses classes. So the very first thing is, previously in order to create classes, and like I said, take this with a grain of salt because actually there's no classes in JavaScript. And again, JavaScript uses the prototype-based model. But in order to create quote-unquote classes in using the older traditional JavaScript syntax, you would essentially use functions. And so functions in this case would basically act as object constructors. So one example I'd like to show you, it would be an example of creating a bank account. So in order to model a bank account, we might have a function. We're going to call it an account, and then every single bank account in the real world essentially has a balance, right? And so the function, what it's going to do is it's basically going to assign the balance to the object given the balance argument. Now we can already create a new instance of the account, and basically it's going to be an instance of the account class or account function, and the starting balance, let's say it's going to be $1,000. We can already console log account.balance. And of course, as you would expect, it's going to give us $1,000. Now, if you wanted to attach some kind of behavior to the account class, you would need to create a function or a method. So one way to do it would simply be to assign the function to a property on the function constructor or the object constructor. So one of the behaviors of a bank account would be to deposit some kind of an amount to it, right? So we could create a function that might be called deposit. We might just simply pass an amount to it. And all this function is going to do, it's basically going to increment the existing balance with the amount that you pass to it. So we already have an account here. Let's do account.deposit. We're going to deposit $200. And once that's done, we're going to console log the account balance once again. And as you would expect, first we get 1,000. Once we add 200, we're going to get 1,200. So that's simple and cool. The only problem with this approach though, and it works perfectly fine, but the only problem with it is that every single object that we create out of the account class is going to have its own copy of all the properties that the function defines. So in this case, we define the balance property, but we also define the deposit method. And again, it's also a property, but in this case, it's not a value like a balance, right? It's not an integer like 1,000. It's actually a function. Now in this case, balance is going to change, right? So if we created, let's say, account 2, and it's going to be a new account. Let's say the balance is going to be 550, and we did console.log account 2.balance, and then we wanted to deposit a new amount into it, let's say $100, and then we did a console log of account 2.balance, and of course I misspelled it, it should be deposit. But once that happens, you're going to see it's going to be incremented by 100. So like I said, balance is going to be dynamic. It's going to change from object to object. But the deposit function, well, it's pretty much the same every time. The behavior is going to be the same. So there's really no point in copying over the same function for every single object that we create. It's kind of a waste of memory if you think about it, because it's going to be the same function, but it's going to be recreated every time a new object is instantiated. So like I said, it's basically a waste of time, and we want to avoid it at all costs. So in order to avoid this situation, one way we can approach it is basically by the use of the prototype. Now we talked about the prototype a little bit, but essentially a prototype, like I said, it's an object that every single object in JavaScript is going to have. It's like an internal property that you can attach properties or methods to it, and those properties and methods are going to be shared across all the objects that you create. So in this case, we have an account. We're dealing with an account, and let's say that an account is going to have a prototype, and we're going to attach a deposit function to that prototype. So it's going to be a function. We're going to pass an amount to it, and it's just simply going to increment the balance with the amount. So now in this case, you get the same result, you get the same output, nothing changed. It's the same behavior, but in this case, the difference is that this deposit function, well, it's going to be shared across all instances of the account class or the account function, so that each one of them is going to have the same instance of the same deposit function. In other words, the deposit function is not going to be recreated for every single instance. Now, so how would this look in ES6 using a class notation? Well, in ES6, we have the new class keyword, and it basically allows us to create classes. So in this case, we're dealing with the account class. Now, in order to have a constructor, previously we had to resort to functions. So we basically used functions as object constructors. In this case, we can use a special constructor method, and we're going to pass a balance into it. So the constructor is going to receive a balance, and we're just going to assign the balance as a property to the object, right? So we can already create a new account instance. It's going to be a new account, let's say 700 as a starting balance, and then we can console log account.balance, and of course that's going to give us 700. Now in order to add a function to the class, we would use a new notation of defining methods. We basically have a deposit, we're going to accept an amount, and then the body of a function is basically going to contain this logic. It's going to increment the balance by the amount that you pass. And so that's how you deposit money into the account. So now we can simply call account.deposit, let's say 100, we console log account.balance. And of course I misspelled the deposit. Now fix that, and you see it's going to be incremented by 100. Now this deposit function, it's not going to suffer from the same issue as we had before. So this deposit function is actually being defined on the prototype. And in fact, if you wanted to prove that, you could basically do a console log of the deposit function, right, with the deposit string in the account prototype, and this returns true, meaning that the account prototype contains the deposit function. So like I said, the deposit function is being created on the prototype. It's not being created as a property on the constructor. You could still technically do that, but like I said, really it's a waste of memory and there's no reason to do that. Now the other thing that you might consider when dealing with objects in JavaScript is getters and setters. So one of the problems, as you can see here, is that we have direct access to the balance data property on the account. So this means that we can actually use the account balance property and initialize it to any value that we want. So we could either assign it to negative values, or we could even assign gibberish to it, and it's still going to work, because if we console log the balance, of course, it's going to be the new value that we assign to it. So this is, of course, not ideal, and if you are familiar with object-oriented paradigm in modern languages, well, essentially one of the concepts that it has is known as encapsulation. It's essentially a paradigm in which you want to make sure that data properties of classes and objects are hidden from the outside world, and you essentially only expose some kind of an interface that allows you to interact with those data properties in a safe way. So in this case, one of the ways to deal with this would be to use a simple convention that basically uses the underscore. So we could, instead of using the balance, we could just assign underscore balance as the property. And in this case, of course, we're not going to have access to the balance, but we can still create what's known a getter or an accessor, which is basically a special type of function that is just simply going to return the balance of this account. So in this case, one of the ways to do this, and of course there's multiple ways, but one of the ways is to use the object-define property method. And the first argument would be the account prototype. The second one would be the name of the property. In this case, this would be balance, right? And the last one would be the actual getter. So in this case, we can use a special get keyword. Then we're going to use the function, and all it's going to do is just going to return this dot balance. And in fact, it's going to return this underscore balance, because if you return balance, you're basically going to end up with an infinite loop that it's basically going to call the getter again and again. So in this case, you can see that we get the new balance. And of course, this assignment fails because we no longer have the balance property. Now, in order to work with that, we might need to create a setter. Now, in this case, it makes sense to call our setter balance. Now, one way to do this would be to use a method called define properties. But because we already have the direct access to the prototype, it's simpler to just simply assign a complete new object to the prototype and define everything on it. So we're going to move the deposit function inside of that object. So it's going to be a property, it's going to be called deposit. Then we're going to have a getter, which is basically going to be the balance function. It's just going to return the current balance. And lastly, we're going to define a setter, which is going to accept the new balance. And then, so we don't need any of this stuff, we're going to kill that. So inside of the setter, like I said, if we want to protect ourselves from being able to assign negative values to the balance, we can have an if condition that says if balance is less than 0, we could just simply throw an exception and say balance cannot be negative, right? And otherwise, we're going to assign this balance equals balance. So in this case, as you would expect, here, this is still going to work, right? Because we're not checking for any strings. But if you try to assign, let's say, a negative 500, you're going to get an exception because balance cannot be negative. Now, this is quite complicated, and again, like I said, there's multiple ways to go about it. In ES6, there's actually only one way to do it, and you would use this special get keyword again, so you can have your balance. This would be a simple getter. It would return this balance. The only thing here, like I said before, you got to be careful with the names. So in this case, you're actually going to run into maximum stack size exceeded exception, because you're calling your getter with the same name, and basically what the getter does, it calls itself with the balance, right? So that's not going to work. So one way to go about it is to use this special underscore notation. Basically, the underscore balance is still going to be accessible. Like you could still do account dot underscore balance, it's going to give you access to the balance. And you could also, in fact, do account dot underscore balance in order to assign any kind of gibberish value to it. But again, by using the underscore, it's sort of like a notation to hide your values, even though actually they're still public and they're still accessible. Like I said, there's no notion of public, protected, or private in JavaScript. Both in ES6 and ES5, all the properties of an object are public by default. So this underscore notation is just simply a convention that allows you to sort of like have a workaround around that issue. So going back to our getter, to make this work, we just need to add the underscore to the balance, and this should work. And then finally, the setter could also be named as balance, and you could pass the starting balance to it, and you simply do this. And of course, you could move the same logic as we had before to the new setter. Now, to illustrate a concept, we can have our account.balance, and we could console log that. So let's console log that, and then we can do account balance. Let's try to assign 1000 to it, and then do console log account balance again. No exceptions so far. First we get 700, then we get 1000. But if we try to negative 1000, of course, that's going to fail with the exception right there. Now, lastly, when it comes to inheritance in JavaScript works with prototypes. So let's say in this class we had a new class or a new function, and we're going to call it premium account. So a premium account, let's say it's a special type of an account where you also have the balance, but let's say you also have bonus points, right? So the very first thing you need to do is you still need to call the original account, right? Because we're going to extend the account class. And you're going to need to pass this keyword, which is basically this object, and also the balance, so that the balance will be properly initialized. Lastly, we can also assign the bonus points to the object, just like so. And then there's two important things that you would need to do. The very first one, you need to call the premium account prototype, and you need to assign an instance of the account to that prototype. And in fact, in this case, you could also use object.create with the account. But in this case, I would just stick to using a simple instantiation of the account class. And the second thing you would need to do is you would need to assign the constructor on the prototype to the premium account class. And once you do that, we're basically set, and now we can create instances of the premium account. So let's say we have a premium account. It's going to be an instance of the premium account class or function. We're going to have a starting balance of 500. Let's say we have 100 bonus points. And we just want to console log premium account underscore balance just to see the underlying values, and as well as premium account dot bonus points. Now in this case, as you would expect, we get 500 and 100. But in this case, we also get access to all the getters and the setters, as well as the deposit function. So we could do premium account dot deposit, let's say $100, and after that we want to console log the premium account balance. Now in this case, notice we're using the balance getter to get the value of the balance, as opposed to accessing the property directly. So in this case, all the functions and all the properties are inherited using the prototype. And the interesting thing is, if you want to go deep and actually see what the prototype looks like, you could do console log premium account dot prototype. And in this case, it actually returns undefined. But if you did proto, this would make more sense. They would actually return you an object that has balance, that has a constructor with a premium account like we assigned right there, and it also has the proto object with all the methods as I explained before. So how does inheritance work in ES6? Now in ES6, the syntax is actually much simpler. So you would again have a class, right? In this case, it would be a premium account class, and what you want to do is you want to extend the account class, right? So you would still have your constructor, and you would pass your balance, and you'd also pass your bonus points into the constructor. Now, in order to call the constructor of the parent class, like we did in the previous example on the left, right, we did account.call. In this case, in order to do that, it's much simpler. You just simply call the super keyword, and you pass the balance into it. So it's basically going to call the constructor of the parent class with the balance. So the balance is going to be set in that method. And lastly, we're going to do this bonus points equals bonus points. So let's see if that worked. Let's create a new premium account. It's going to be a new object of premium account class. We're going to pass, let's say, 900 and 100 for bonus points. And then we're going to do premium account dot balance. Again, that's going to be our getter. We're going to do console log of premium account balance. And then we're going to do, let's say we're going to use the deposit method just for the sake of it. We're going to deposit $100. And then last, we're going to do our console log of the balance. So we get 900 as you would expect, and we also get 1000 once we call the deposit function. So again, in this case, again, all the functions and properties are inherited in the child class, and you also have your bonus points right there. So at this point, you can already extend the class by creating new getters for the bonus points, and so on. One thing you could also do in ES5 is you could use what's known in other languages as static functions. So static functions are basically, or methods, those are basically methods that you call off the class without having to instantiate the class as an object. So in this case, one of the methods that would make sense would be to register a bank account. So we might have a register function. In order to register a bank account, you would need a starting balance, right? So once we have the balance, we could simply return new account balance. So it just creates an instance of the account class. So I'm just going to kill all the older examples that we had. And let's try to do console log account dot register, and we're going to pass 600 as the balance. Right, it's going to create an object for us, and it's going to have all the functions and all the properties. Now you could still do the same thing in ES6. And in order to do that, you could use the static keyword. So you might have static register. You're still going to pass the balance. And then lastly, the body of the function would simply return you the new account instance. And it's still going to work. In fact, I'm going to kill the older examples. Now let's do console log account dot create, or actually we'll call it register. Let's pass 900. It's going to give us an object with a balance of 900. And again, of course, you could still call all the different methods and access all the properties that the account class or account object has. Now, to wrap up this video, I'm just going to mention a few things about ES6 classes. So like I said before, ES6 classes don't actually introduce a new concept in JavaScript. JavaScript still uses prototypes under the hood, so all of this syntax that we have right here is actually being translated into ES5. And actually, in order to prove that, I'm going to do a simple trick here. So let's look for ES6 compilation online. Let's see, I'm looking for the Babel website, and I think it's right there. So if I were to copy over our account class right there, let's just paste it over here, and let's prettify it also. So as you can see here, this is basically the website I'm on is babel.js.io. What we did right there was we basically added our account class, and Babel essentially compiled our class into the traditional ES5 form. And you can see right here that we have our good old function constructor that creates the account. We assign the balance, and then there's a whole bunch of methods here. You can see the getters, our getter, you can see our setter, and you can also see the register static function that we created. So again, at the end of the day, ES6 classes get compiled to ES5 functional classes. And the other thing to keep in mind, one of the tricks is that classes in ES6 don't actually have or don't actually allow you to create static properties. If you're familiar with ES5 prototypes, using prototypes, you can not just only create functions, but you could also assign properties to that prototype. So let's say we could create a shared value or a shared property of minimal balance, and it would sort of like make sense, right? So my minimum balance would be 0. So in this case, every single object that's being created is going to share that minimum balance value, right, or property. So we could do a console log of our, well, we could do new premium account, and I'm just gonna wrap it in parentheses, and I'm gonna call minimum balance off of it, and let's see what value we get. We get 0. So no matter how many instances you create, they're all gonna share the same minimum balance property. Now you can't actually do that in ES6 at this point. There is a proposal that's known as preset stage 2, which sort of allows you to use the static keyword in order to create static properties like so, but still it's sort of like a proposal. It's not been integrated into the core language, so we can't be sure if it's going to become part of the language in the future or not. So for now, you can't really define static properties on classes. And the other thing to note is in ES5 you could not only instantiate classes using the function keyword, but you could actually call the account as a function, and still it's going to work, it's not going to break. Well, that's not really the case with classes. You can't simply just do account as a call, because account is a class, so it's not callable, and in fact you're going to get a type error. It basically says that class cannot be invoked without the new keyword. So the only way to invoke the class would be to use the new keyword, which is basically what we did right here with the premium account. But with the case of ES5, you could still call the function, because we're not dealing with classes here, we're dealing with functions. And then the very last thing I'm going to mention, because I know it's already pretty long video, but the one thing you need to keep in mind is when you deal with functions. Now we talked about functions in previous videos, and also mentioned the notion of scope. Now, when we deal with scope, scope is an interesting thing in ES5 or JavaScript in general, because in JavaScript there is a concept that's known as hoisting. Now, hoisting, like I explained before, is essentially a behavior of JavaScript in which JavaScript compiler basically moves all of your declarations, be it variables or functions, to the top. So that basically allows us to, in this case, create an instance of the account even before the account is created, sort of. So we could do new account and pass the balance. We could do console log the new account object. Sorry guys, my audio got screwed up. But basically what I was trying to explain is that if you have a function, no matter what kind of function, if it's a constructor function, or if it's just a regular function, it's perfectly valid to call that function, before it's written in your code. And that's because when the JavaScript code executes, the function sort of like moves to the top of the scope. And not just functions, like I mentioned in the previous video about hoisting, but also variables. So with functions, it's possible to call a function prior to when it appears in your code. But of course, in ES6, that's not possible with classes. So you can't, let's say, have a declaration or initialization of your class before the class is actually defined. So it's necessary to first write the definition of your class, and only after that can you, create instances of that class. Now when it comes to classes in ES6, what you've seen so far is basically class declarations. And that's when you have the class keyword, and you have the name of your class, and then you have the brackets, basically the body of your class. But just like with functions, you could also assign a class to a variable, just like you would do with a function. So you might have something like let account equals class, and then you might have your account keyword or not, it's optional, and then you have the body of your class. But the difference between class expressions and class declarations is that with class expressions you could actually redeclare a class. So it's just a little tweak, just a little thing to keep in mind that might help you down the road. But other than that, class expressions and class declarations work pretty much in the same way. So just to reiterate, the very last thing, I know this video is pretty long, but just to recap sort of all the things that we covered the different ways to create methods, setters as well as setters and getters, and also static methods on classes in ES6. We've seen how inheritance works with the extends keyword, and we also realized that classes don't actually introduce a new object-oriented model They basically just provide you with a sugar syntax for ES5 functional classes. So they sort of allow you for more flexibility, shorter code, more concise code that also resembles other object-oriented languages, as we mentioned, Java and C#. So that is basically it for classes. Thanks a lot for checking out this video, and I'll get back to you with the next one. Thanks a lot again.